Good day, everyone. Today we will present our Calculus 1 analysis of two fast food giants in Malaysia, KFC Malaysia and McDonald's Malaysia. We have chosen to analyze the optimization of daily production costs. This process is vital as both companies must balance high production volumes with efficiency operational costs. As you guys can see, here some products of KFC, which is fried chicken, burger wraps, side dish, and drinks. Some service that KFC give is dining restaurant, takeaway, delivery, and drive-through service from ordering ordering from vehicle. General background: KFC has founded by Harlan Sanders in the 1930s. The first franchise of KFC is in Utah. Now the owner is currently part of Yum Brands. In Malaysia, it's managed by KFC Holdings Sdn Bhd. Marketing of KFC is used a marketing mix, which is product, price, promotion, and distribution to remain competitive. This is some backgrounds of McDonald's. McDonald's serve products such as burgers, french fries, fried chicken, breakfast, ice creams, and drinks. The famous burgers that McDonald's serve such as Big Mac and Quarter Pounder. Some service that McDonald's give to the customers is fast ordering at the counter, drive to delivery, and a standardized restaurant experience worldwide. Some general background about McDonald's is origin started by brothers Dick and McDonald in 1940, then introduced the split service system in 1948, which became the basis of fast food. Expansion: Will Kroc, a machine salesman, saw the potential and opened his first franchise in 1955, which is considered the official founding date of McDonald's by Kroc. McDonald's globalization developed into an international brand known for standards of quality, clean lines, and consistency product worldwide. Some commitment from McDonald's in Malaysia: McDonald's is also involved in vocational training programs for young and focused on employee welfare by offering a competitive minimum wage in line with its corporate vision. In this section of the analysis, we look at the foundation of our study: daily production cost optimization. Both KFC and McDonald's aim to minimize their operational expenses while maintaining output. To do this, we represent their complex daily workflows using specific mathematical functions. In both formulas, FT represents the production cost in ringgit Malaysia, while T represents time throughout the operational day. By using cubic function, which involve T power the power of 3 and T the power of 2, we are able to model a nonlinear cost structure. This means the model accounts for the fact that costs and don't just stay the same. They change based on peak hours, energy surge, and labor shift. Now, let's look at the specific parameters for each company. For KFC, the function starts with a constant value of 3,000, which represents their daily fixed operational cost before any production begins. For McDonald's, their fixed costs start higher at 3,200. Notice that KFC has slightly higher cubic coefficient, that's 0.00005, compared to McDonald's 0.00004. This tells us that while McDonald's start with higher overhead, the rate at which their costs accrues over a long period of time is slightly different from KFC. By defining the functions, the companies can perform optimization. They can identify exactly when costs are spiking and use calculus specifically derivative to find the minimum cost point.
After we settle a positional processor and mathematical function, we proceed with first derivative. For KFC, the function is 0.00015 power of 2 minus 0.05t plus 50. After we got the function, we need to equal the function with 0 to get the value of t. And we get the t is 200 and 216. After we get the value, we need to test the value to get the behavior, to compare the behavior with to the value. First, we substitute t with 200, we got 5, and we substitute the value t with 216, we got 4.34. So the behavior is increase. The behavior is changed from increase to decrease. And the function for McDonald is 0.00012t power of 2 minus 0.06t plus 14. After we got the function, we equal the function with 0 to get the value of t. The value we got for t is 150 and 250. After we got the value, we need to test the value with substitute t equal to 150 and we got 7.7, and 250 we got 6.15. After we settle find first derivative, we need to find the critical point. To find the critical point, we need to differentiate again the function at the second time. The function for KFC is 0.0003t minus 0.08. After we got the function, we need to equal the function with 0 to get the value of t. So we get t equal to 2, 6, 6 and 6, 7. And we need to substitute the value of t to get the value. So the value is 4.33. So the critical point is 266.67 and 4.33. The classification is local minimum and the interpretation is at t equal to 266.67. The rate of change of KFC function reaches its higher value. This means that KFC performance increase before t equal to 266 and 67 and start to decrease after this point. Therefore, t equal to 66 and 67 represent the most optimal time for KFC before its performance begin to decline. And the function for McDonald is 0.00024t minus 0.06. After we got the function, we need equal the function with 0 to find the value of t. So the value of t is 250. After we got the value, we need to substitute the value in the function to get the value. So the value we get is 6.5. So the critical point is 250 and 6.5. The classification is local minimum and the interpretation is at t equal to 250. The rate of change of McDonald function is at its maximum. It at minimum. This means that McDonald performance increase before t equal to 250 and decrease after this point. Thus, t equal to 250 is the time when McDonald performance is at its best.
To understand this trend more deeply, we have developed cubic cost function for both companies. KFC's cost is defined by the function ft equals to 0.00005t to the power of 3 minus 0.04t to the power of 2 plus 15t plus 3000. While McDonald's follows, Ft equals to 0.00004 t to the power of 3 minus 0.03 t to the power of 2 plus 14t plus 3200. This function accounts for the complexities of production, while costs don't just rise linearly but fluctuate based on output and time-based variables. By plotting this, we can see that McDonald's, shown in pink, operates at a higher cost ceiling than KFC, shown in blue, throughout the day. In this analysis, we are evaluating the production cost efficiency of two industry giants, KFC and McDonald's, using hourly data over a 24-hour cycle. We have modeled their spending patterns to see how they compare. As we look at the initial data table, we see costs recorded at various intervals. From the very start, a gap is visible. At time 0, KFC began with a production cost of RM3,000, while McDonald's start slightly higher at RM3,200. This trend continues across every timestamp measured, with McDonald's consistently maintaining a higher cost profile. However, to find the total daily production cost, we must look beyond individual hours. We use the definite integral to calculate the total accumulation of cost from t equals to 0 to t equals to 24. For KFC, integrating their function over the 24-hour period results in a total daily expenditure of 76,139 ringgit 83 cents. Applying the same calculus to McDonald's, we find that despite having a slightly lower cubic gross coefficient, their higher base cost leads to a significantly larger total area under the curve. Their total daily cost accumulates to 80,697 ringgit 8 cents.
In conclusion, based on our calculus analysis and the data visualization, we have decided that KFC Malaysia has a better mathematical outlook for this specific production scale. Our justification is that KFC demonstrates better cost efficiency in the early stage of production. This data align with their reported 25% revenue growth in 2024. All our findings are supported by the reference provided in our report. That concludes our presentation. Thank you for your time.